All right. Hello and welcome everyone to today's session of the MZES Social Science Data Lab. My name is Dennis Cohen and I am happy to welcome you to today's workshop by Andreas Küpfer on using Twitter data for social and political research. The Social Science Data Lab is an event series here at the Mannheim Center for European Social Research, where we present a platform for tools and methods for the collection, management, analysis, and visualization of data in the social sciences. The Data Lab is organized by myself in collaboration with my colleagues Cosima Meyer and Julian Bernauer. Our speaker today is Andreas Küpfer, who is a recent graduate of the Mannheim Master in Data Science. And since the beginning of this week, he's also a doctoral researcher at the University of Darmstadt. And on top of that, for the next 3 months, he will still be my research assistant and as such also a supporter of the Social Science Data Lab. Andreas's interdisciplinary research interests include text-to data and machine learning technologies, as well as substantive inquiries in the fields of political communication and political competition. Andreas's talk today is split into 2 parts. In the first part, he will give a general introduction to the use of the Twitter Research Track API for the retrieval and processing of Twitter data. This talk will essentially, or this part of the talk will essentially stop at the point where you have a full corpus of tweet that you can use and process as you would with any other collection of textual data. Part 2 then will be based on will focus on a substantive application where Andreas will show insights that have emanated both from his research assistance for me as well from his master's thesis, where he will apply a collection of tweets from German members of parliaments to the estimation of position and salient scores on specific policies. About the logistics for today's talk, you may ask your question during the talk if it's for clarification, or after the talk in the Q&A for broader discussion questions. And whenever you want to ask a question, you can do so in the usual ways. You can either raise your hand in Zoom and we will call on you and ask for you to unmute yourselves and speak. Or if you'd rather not want your audio and video to be recorded, you can post your question in the Zoom chat or send me a direct message, in which case I will read it out for you. Just once more, the disclaimer: we are recording this live stream in active speaker mode, which means, and we are going to post it to our YouTube channel eventually. If you do not want to have your audio and or video recorded, please do not unmute yourselves and speak and use the chat instead. So with that being said, Andreas, thanks so much for doing this today, and I look forward to your talk, and the floor is yours.
All right, thank you, Dennis, for your introduction. I try to share my screen and hopefully you can see my slides now. So yes, I would like to talk today about the collection, management and analysis of Twitter data. First part, Twitter API for academic research, and the second part, an application based on Twitter data using BERT. Let's step right into it. And first, I would really like to talk a little bit about social media data itself and about the richness of them, because as you, I think, already all know, like, social media posts are full of potential, at least after filtering out bots and other like spam and nonsense. And but then they're really good to do data mining and text analysis. And also the platforms recognized this potential and increasingly restrict the free access to such data. For example, Instagram restricted its API access during the last few years, and also Twitter did the same until the beginning of 2021, when they released their new Twitter API version 2. And with that, you're able, at least for academic purposes, for free to crawl the whole timeline of tweets with some conditional, but more on this later. But still, you're able to crawl all the tweets of a user, of some containing some special hashtags or anything else from, I think, since 2005 or 2006. And this will hopefully continue after Elon Musk introduced his free speech on Twitter. Let's see. But yeah, first, as like most, or at least a lot of people see Twitter having a lot of textual data, like tweets. But Twitter research isn't really about only textual data, because there are a lot of other resources which you can retrieve from Twitter, also using the Twitter API. So for example, when looking at social network interactions, like followers or likes, without any textual parts, it often reveals valuable information. So to give an example, you can retrieve ideological positions from follower networks, or you can compute some kind of an importance of a user within a social network, just looking at how many followers somebody has and how many people he or she is following. And yeah, what you see down there is some kind of follower network using the Twitter network of members of the German Bundestag. It's just some kind of visualization, also seeing the different parties. And I think it's quite just nice to see the connections between the users. And apart from that, so you have textual data, we have the social network interactions, but we also have shared media elements, for example, pictures or videos, which can be for sure analyzed and also combined with textual data probably. And they can also be retrieved with the Twitter API. So just to have some small overview, it's just a small selection of ongoing work and also previous work with Twitter data, starting in 2010, maybe also before, but there was the rise of working with like Twitter data and social media data, and it's getting more. So the attention is increasing, and more people working in different fields, not only political science, also sociology or economy. And yeah, so there are a lot of papers. It's just a selection, and if you want, you can take a look at it. But what we want to do today is having a deep dive into the new Twitter API in detail. And before doing that, I think it's important to know what happened before. So looking at the old API, it was Twitter API version 1.1, and it was like the main API until December 2020. And at least in the free standard version, there was no full archive search available. So you were not able to retrieve all the tweets of a user or like the whole timeline. You were able to just retrieve the past 7 days, or at a maximum of 3,200 tweets. And also there was a smaller range of retrievable metadata. So when you retrieve a tweet via the API, you get a lot of metadata attached to it. For example, the likes, or how many times it was retweeted, and so on. And also this increased with the version 2 of the academic research API of Twitter. Furthermore, there were less query options. What a query is and how to like use it with the Twitter API, we talk about it later, but just to know, there were less query options in the old API version. And to make it complete, there also was a premium API back then, but yeah, it was premium, it was not free. And I think it's really an important change that everything is more or less free for academic research now. Yes, so going to the version 2, the current version, which is available since January 2021. To understand the different tracks, the different product tracks, there is some small screenshot coming from the Twitter developer platform. And there is the standard track, which is, yeah, it's free, but it's also limited. You cannot retrieve that many tweets, and there is also no full archive search available with the standard track, but it's available for everyone. Then there is the business track, where you can have the full archive search, and you can have a lot of different parallel applications running. And then there's the academic research track, which is kind of like the business track, but with less parallel applications and yeah, free of charge, which is, I think, the main selling point, and also in yeah, made for academics. Yeah. And this is also the track where we like work on, and where we yeah, doing the stuff in this presentation today. To know the like the framing of the Twitter academic research track and of the Twitter API itself, we have to see that you always retrieve some kind of objects. Yeah, so when you request the API, you get kind of objects back in the response. And I think it's important to see that there are two, let's say, main objects, which are, I think, the most important objects, and those are tweets and users. So tweets means, so there is the text of a tweet, maybe there is the author ID, there is the tweet ID, there are some meta information, some more. And then there is the user object, where we get information about the user, so the description, user ID, I think also registration date, and so on. So a lot of metadata. And apart from that, there are way more objects which you can retrieve via the API, for example, media. Or spaces, like recently, and I think even more during the Ukraine war, it was quite often used as spaces, so you can see it like a Zoom room, maybe similar, and you can join a space, and there are a lot of talks about the situation, and yeah, you can just talk to each other. And then there are lists. Lists means that for example, there are lists of the members of the German parliament, which are on Twitter. And then there are places. Yeah, it's just some kind of geo places which are published on Twitter. And then, apart from the main objects or of the objects which you can retrieve, there is one important restriction, and it's called the tweet cap. So you can retrieve not more than 10 million tweets per month. This is quite a lot, at least it sounds quite a lot, but you have to imagine, like, if a user has sometimes 10,000 tweets published, and you have 1,000 users in your list, then you get quite fast to this tweet cap, but still it's a lot, yeah, and it's per month. So we have to wait 1 month, and then it's reset it, and you can start from the beginning. The second point are query rules. It's just good to know the restriction that a query rule, and on the next slide we will introduce the query rule, has cannot be longer than 1024 characters, and this is just some kind of search string. Yeah. Then the streaming rate. So there is a restriction that you cannot do more than X, depending on the endpoint, requests per 15 minutes. So just to prevent an overload of the servers of Twitter, they reduce the amount of requests in a given time interval. And if you like try to request more, you have to wait. So the API says you, okay, you have to wait like 1 minute, 5 minutes, depending on the situation. It's for free. And definitely other limitations are that you cannot retrieve removed tweets. You cannot retrieve deleted accounts or tweets coming from deleted accounts, or accounts which you blocked. And so this is important to keep in mind when working with Twitter, with the Twitter API. also looking at replication issues and so on. As I promised, we talk now about queries. So imagine you have your idea for your research application, and you want to retrieve a set of tweets, and usually you don't want to crawl whole Twitter, but you want to narrow down your search. And to do this, you can create queries. So for example, this query would be maybe interesting if you, in case you want to analyze tweets containing the keyword Putin or the keyword Zelensky, and the tweet has to be a retweet, and the language has to be English, and the tweet needs to have some location attached to the tweet. And if a tweet matches this search query, then you get it back, and if not, the API won't put it into the response. And there are a lot of different combinations possible with the query, and it's quite powerful. And yeah, you can read more on queries using the link below. I will also publish the slides so you can read a lot. It's all coming from the Twitter developer blog or the documentation. So yes, then a second concept, which is good to know when using the API, and also good to see why packages are really important to use when crawling tweets, is the concept of paging. So you have to see if you crawl 10,000 tweets, for example, yeah, you do a request with a query, and you think, okay, I get 10,000 tweets back, for example. Then those tweets won't come back in one package, but they are split into several packages of small sizes, and these packages are called pages, and you have to iterate from page to page until you retrieve all the tweets. And what you see here is just some kind of next token. I think it's the most important meta information, and this block comes back with every package or page of tweets in the response. And using this next token, you get on the next page. And yeah, that's just the main concept, I think, of how the API works, and also more on paging using this URL. Then the rate limit. It's also, yeah, I just already talked about it a little bit at least, but it's, yeah, well explained with the phrase, it's the maximum number of requests in a given time interval. For example, I think the most important endpoint, at least for text analysis, is the full archive search, which is only available in the academic track or in the premium track. But you are limited to 300 requests per 15 minutes per environment, and as well as a maximum of 1 request per 1 second. And environment is just some kind of, so you have to imagine you have create a project in your Twitter API account, and the project can have several environments where you can crawl tweets, maybe also in parallel if you need that. But that's just an example for a limit. All the rate limits are down there. And normally you also don't have to think a lot about rate limits when using packages to crawl tweets. Having this information, this basic information about the academic track and how it works, it's, yeah, sure important to know whether you're eligible or not to get in access to the academic track, because there is some application process, and yeah, to use the application process, or at least to have the chance to get admitted, there are some prerequisites which you have to match. So you have to be either a master student, doctoral candidate, postdoc, faculty, or research-focused employee at an academic institution or university. Then you need to have some research objective and plans, also how you use, analyze, and share Twitter data. And you also have to write this down in your application to Twitter. So you somehow need to know what you want to do with the data and how you want to retrieve it. And yeah, I think this is quite obvious. It's also not just allowed for non-commercial purposes. Then when you're at the point that you like, I want to apply for the access to the Twitter academic track API, there is a good page of the Twitter developer platform website. It's quite easy. You click on apply, and then you straight get to the application process page. And there are 5 steps basically. And the first step is the basic information step, and there you just provide information about you. You have to verify your phone number, select a country, and for sure you need in beforehand a Twitter account to get there. So this is mandatory. And in the second step, you have to share your academic profile. So you need some kind of official profile somewhere. So your department website or your similar things like that, just that Twitter is able to verify that you're really an academic, an active academic. Yeah. In the third step, and I think this is the most sophisticated one, you have to provide information about findings, about the description of the project itself, and how you intend to use the API. So which methodologies you want to apply, how the outcomes will be shared. And this is a really important point, because if you like write something down before reading the terms of Twitter, the developer agreement, then maybe you won't get access, because yeah, we talk about this later, but you don't you're not allowed to publish, for example, tweets itself, and but we talk about this later, so you will manage it somehow, definitely. The last 2 points, review and terms, yeah, it's just some overview of the previous steps, and then you have to agree to the developer agreement and policy. And just to say the project details, I think it's like 200 words for each description of the project and each like methodology section. So it's not that much, but yeah, just some things you have to share with Twitter. And after the submission of the application, you receive a decision, I think, usually within a few days. At least for me, it was always, yeah, within like 2 or 3 days, maybe also on the same day sometimes, but yeah, that's it so far. So after receiving the decision and after you getting access to the developer portal with the academic track, you see this kind of menu on the left side, and what you can do with these options are mainly maybe 4 things. So you can manage your projects and environments. So environment, as I already told you, belongs to a project. You can create, I think, the academic track 1 project at max, and up to 3 environments. You can generate API keys. API keys are, yeah, I think, well translated as with credentials for your API access. So it's some kind of username and password equivalent. And then you get an overview of the real-time monthly tweet cap usage, which is interesting to see just the progress, how many tweets I can still crawl. And then you can check available API endpoints and some specifics about it. There is, I think, a really good documentation about the API endpoints. It's down there on the left side, seeing the Twitter API v2. And yeah, all endpoints are explained with examples, and yeah, like just good practice to see how they can be used. So having this overview, we would like to create a project now. And what's the most important step when creating a project is, in the end, you receive an API key, or better to say 3 keys. And what's really important is that you keep them private and do not push them to GitHub or similar, because it's quite common that people forget to like add the environment files, for example, to the git ignore or something, and then they push their information to GitHub, and everyone who's reading the API keys can use it and can maybe do bad things with your tokens. So this is the most important thing on the slide. And the other things are, you get an API key, which is kind of your username for the API. It's called the consumer key. Then you get the API key secret, which is kind of your password. It's also called consumer secret. And then the bearer token. This is a special access token. So it's depending on the package and application which you use to access the API, which keys are important and which keys you need to include. But yeah, just store there somewhere at a safe spot and to use it in your package or application. So then we at the point, okay, we have access to the API, we have our keys, and now we would like to start crawling. And there are various ways to crawl the tweets. So there are packages in Python or R, and there are more ways to get the tweets. And some are comfortable, some are quite uncomfortable. And Postman is comfortable to get some first like playground, to have a playground to get first results, to try out queries, to try out the own tokens. And Postman is just some kind of application. You install it on your local machine, and you don't need any programming language. You can just try out the API. It's different API endpoints, yeah, that's it basically. Yeah, and just to see how it works. Yes, I use it often not only for Twitter APIs but also for different APIs to see how the API work. And with the data, and we're done with this part. There are several points which definitely show that we need a package and need at least some programming code to get access to a lot of tweets. Because usually we don't want to just crawl 10 tweets, we want to crawl like 10,000, 100,000 tweets. And the first point why we need packages is because packages can build flexible queries. So they can, for example, you can put in a list of users, and the package builds, or programming code, or the package builds a query to retrieve tweets of several users. Or the next point is that when you want to handle large responses, they come split up in pages. And if you want to do this by hand in Postman, it's just not, it's not possible, I think, to like write down 10 or 100 next page tokens. Then the packages usually do handle the rate limit restrictions. So they say, okay, I request automatically 10 times until the API says, okay, you have to wait. The package is waiting until it can do the next request. So this is also an important thing why packages are nice, and we should use them. And the last point is that, they can, with program code and packages, we can just transform the responses into manageable data structures, maybe a data frame, an RDF object, or CSVs, so to make some analysis on it. So what kind of packages are there? So there are a lot of packages, but some packages don't really work for the version 2, the academic track. But at least for R, at least in my opinion, there are two really good packages. One is Academic Twitter and R Twitter v2. And for Python, there is Search Tweets v2, which is the official package of Twitter, developed by Twitter, and Tweepy. And now we know the package, we have access to the API, so we can start writing code. We just have to decide which programming language we would like to choose and which package we would like to choose. So we use our academic track API access, where we can extract our personal API token. And in our case, for this code walkthrough, we crawl German MPs, the tweets of German MPs, with academic Twitter in R. And the upcoming code is just some very basic scenarios. So we can do much more than this, but it's just to show you how easy it is, at least to do the first step, namely getting tweets and storing it and doing some kind of small pre-processing steps. And I would just like to start explaining some lines of code. So in the very beginning, we need to load some libraries, like every time. So we use deployer, academic Twitter, which is the most important one in our case for this process, then Conteda for some pre-processing steps in the end, and per. This is the libraries part, and then there is the authorization part. So setBearer is a function coming from academic Twitter, and it's just some kind of, I think, a good guide to store the API bearer token. So if you call the function, you get some instruction there to store the bearer token, and it's stored in some environment file, and then academic R does like the rest and handles everything. In the next step, so academic Twitter knows the bearer token, and we now have to load user IDs, yeah, because in our case we want to retrieve tweets of German MPs, so we need the user IDs of the German MPs. And so I do just a normal read CSV. I have my list of user IDs and load it in German MPs. The question here is obvious. So where to get user IDs from? And we could say, okay, we just go to Twitter and look at the username and then somehow get the user ID. We can also use the username to crawl tweets, so the user handle, better to say. But the problem is, if you use the user handle, so what you see on Twitter when you like on a user page of some Twitter user, the problem is that the user handle can change over time. It can be changed by the user. The Twitter user ID cannot be changed. So what we can do here, if we have a list of user handles, we can use also the API, for example, to retrieve the Twitter IDs, the Twitter user IDs, or we can just go to some public resources to get the Twitter user IDs of MPs, for example. So there is the Twitter parliamentarian database, which have, I think, a lot of lists for MPs coming from different countries. And then there are public Twitter lists, which are also sometimes interesting, I think. So that one is, for example, a public Twitter list showing the current members of the parliament in Germany. But you have to use them with caution because, yeah, they are public. You don't know who is like maintaining it and so on. But still, it could be a first source of information. And there is the legislator R package, but as far as I know, you just get the user handles. So you have to decide if you want to use the user handle to crawl the tweets, or if you want to then convert it to the user ID. Because if you use the user handle and it changes over time, you cannot crawl the tweets anymore. And also somebody who wants to replicate your studies cannot crawl the tweets anymore using the user handle you published. Yes. So coming to the main part and the most interesting part, I think, of the code walkthrough, because we are at the point we have the list of user IDs, and now we just want to retrieve tweets. Yeah, we want to iterate over the user IDs and retrieve all the tweets available for one tweet, setting some basic restrictions and some basic filters. How is it done? So we have here some walk function walking over all user IDs and calling the get tweets from user function. And it's some custom function coming from me. And it's, I think, really basic because it just calls the get all tweets function, which is from the package academic Twitter, providing one user ID, setting start tweets. So it's a start date and an end date and a path where the tweets should be stored. And the number of tweets per request, which I want to retrieve. So in my case, I choose infinite because I know, okay, a user in my list has a maximum of, let's say, 50K tweets. That's fine for me. But if you use a query instead of a user list, so you can also provide a query as a parameter, then sometimes it's really clever to set a restriction there, upper limit for the number of tweets. And sure, you could also provide instead one user ID. You could also provide a whole list of user IDs, but you have to think about the query restriction because a query string must be shorter than 1024 characters. And in my case, I have quite a lot of user IDs because there are, as of now, a lot of members of the parliament on Twitter. So it would not work. And that's why I decided to choose to just use one user ID at a time. Yes. So I iterate over all these tweets, over all these user IDs. The tweets get crawled. I have some nice output in my console. And then sometimes it happens that, for example, your network connection gets interrupted or the API got some problems. I don't know. And then there is another cool function also coming from the package academic Twitter. You can use resume collection to resume to the point where the crawling process got interrupted, and it starts from then and crawls the tweets which were not crawled already. This is the first, I think, just cool function to use. And the second function from the package is called update collection, where you can also provide a data path and some end tweets date time. So this means if let's say I crawl or I crawled all tweets until January this year, and I want to extend it, I want to update it until today, then I would provide a date of today here in the end tweets parameter, and the tweets get crawled from the last time I crawled it, so January 2022. So those are just two more tools in the package. They are not necessary all the time, but good to know, I think. So we are at the point, our tweets are stored, but they are stored as JSON. So JSON is some kind of data structure which is used in a lot of APIs and in the HTTP context. And there are sure other ways, so you don't have to store it as JSON. You can also store it directly as in an R format in an object. But in my case, I stored it as JSON because it's the standard way of the academic Twitter package. And because I did this, there is a function called bind tweets, and bind tweets is quite simple and cool, because if you call the function with the data path where the tweets are stored and some output format, in my case tidy, you get all, at least most of the information which got stored back, and in a data frame, in a simple data frame, and you can select the columns which you need. In my case, I selected the tweet ID, the tweet text, the author ID, so it's just the user ID which created the tweet, the user name, it's the user handle, the created ad when the tweet was created, and some source tweet type and source tweet text and the language. So source tweet text means if there is some quoting tweet, so there's, let's say, some source tweet, and this is also included in the response, and it's really nice to do some analysis. And then the last part, if you want to store it in case in a CSV format, you can store all the tweets just to CSV and do further analysis, and you're done. Yeah, you have the tweets locally on your machine, and yeah, can work with them. And as it's sometimes when we want to apply methods, really important to do some pre-processing. Yeah, we need to apply some steps, and this really depends on the method at hand. So sometimes you need lower casing, stop words removal, or stemming. Sometimes you need less pre-processing, as for example in the method, an application which I want to explain in the second part of the presentation. I do, for example, just need to remove the at mentions and URLs, but depending on a method. And depending on a method, I want to show some basic scenario how you could do pre-processing, for example. And for that, I want to use the library Quanteda, which is also quite famous library, I think. And we first have the tweets in our data frame. We just use the text column, and we set the document names with the tweet ID just to have some reference. So we are able to re-identify a tweet after pre-processing by the tweet ID. And when we created this tweet corpus, we can use it for further pre-processing. And I just want to briefly explain the steps. So first, we apply the tokens mechanism, which just splits this example tweet above into several tokens. So 2020 is a token, Wurden is a token, and so on. And then removes the punctuation. So these points here are removed. Then numbers are removed. Really, you have to decide it if it's suitable for your method, or if you need the numbers to process the tweet. Then I remove capitalization, and I remove all the stop words, because usually they more like distracting the method. And in the last step, I transform the words to their German word stands. And as you can see, the tweet above, it's the origin tweet. This gets transformed to this kind of tweet. And for example, the stemming here, like if you look at Wurden, after stemming, it's just Wurd. And there are a lot of more pre-processing steps. And as there are a lot of them, it's important to I think, having some literature, some guidelines. And I would just like to recommend you some resources on the Methods Bytes blog. There are also more there, but just to jump into it and having a first impression of all. So now we have some kind of pre-processing. We apply our method, and in the end, the question is how to reproduce. Because if we want to publish something, we also usually have to publish or want to publish our data. But Twitter says academic researchers are permitted to distribute an unlimited number of tweet IDs on behalf of an academic institution. So the point is, actually, we are allowed to publish tweet IDs, but we are not allowed to publish tweet texts, so not the content of the tweet itself. And the problem is that tweets, as already mentioned before, can be deleted, accounts can be suspended, and so on. And you're like people after you, researchers after you, are not able to crawl these tweets. So they have a lack of data and cannot then reproduce your results in a full pipeline. And this is a real problem, definitely. And however, there are some things in between, I think. Just to give you an example, there are platforms which do nothing else than track removed tweets in a real-time manner. And they say, okay, we track public figures, and therefore they justify the publication even of deleted tweets. And usually, if you would publish your tweets, your tweet content, you are responsible to like if a tweet get removed, you also have to remove it in your database, which is just not manageable. at least that's the way the developer agreement is written. Yeah. But if you want to take a look, I think it's just also interesting to see what can be done with the removed tweets. It's on polytweet.org. Yes, that's it so far, talking about the Twitter API itself, how to retrieve tweets and how to do some pre-processing, and issues with replicability. And as I promised you in the second part, I wanted to talk about tweets in action, and therefore about my current research, an NLP application based on BERT. And first of all, I would like to introduce you to the goal of my research. And so the goal is the estimation of legislator level salience and position based on political texts. And we want to have a flexible, less data hungry than traditional methods, at least, pipeline, which is able to adapt to subdomains of policies, different sources. So not only Twitter, but also maybe, for example, Instagram, depending on like the way it is political or not. And as well as languages. So also other languages, and not only German MPs as we used in our demonstration in our application. Our application is about estimating policy-specific legislator level position and salience scores based on the textual contents of tweets using BERT. It's a state-of-the-art NLP model, and hierarchical shrinkage estimators. And second, analyzing variation in legislator level position and salience scores as a function of characteristics of legislators and electoral districts. So we include socioeconomic aspects and analyze this on a district level. And most important, the databases. As we talked a lot about Twitter API and so on, it's important to talk about the databases. It's the German MPs of the 19th and 20th Bundestag, and published between the mentioned dates there. And we used a random sample on a pre-filtered portion of the original tweets. So in the first iteration of the paper, we used some sophisticated process with active learning and pre-classification to see whether the tweet is like domain related or not. But in the second iteration, we decided to stay with a very simpler approach, a dictionary approach, which is similar, produces similar results, and is way simpler. So this random sample is used for annotation. So in the first step of the annotation process, we annotated the tweets according to different domain-related policies. In our case, it was the main policy category housing, and we split up housing into different sub-policies. And these tweets are getting annotated using a multi-class approach. So one tweet could be classified into different into multiple sub-policies. And in the second step, we annotated each sub-policy with either -1 for left, 0 for neutral, or 1 for right, depending on the policy itself. And I just want to show you the different policies which we defined based on the national manifestos of German parties. As you see, these are all housing policies, and some of them are more originally left policies, some are more right. And depending on that, we annotated tweets like that with the position and the category or the sub-policy. And for the application itself and for the method which got applied, we grouped more right policies to, or not more right, but the point 2 and 3 to the private policy group, and policy 1 and 4 to 7 to state. So we have two groups within the housing domain, which makes it, in the first step at least, more easier to work in the model. And the model we applied to do the estimation of on the one hand the policy categories, so the salience part, and the prediction of positions, so the ideology part. We used BERT. And what is BERT? So BERT is, to make it at least a little bit simple, it's a so-called transformer, and it is able to capture contextual representations of each single word in an input text. It's a mechanism called attention, and just to give you an example down there, so there are two sentences. The first sentence is, we went to the riverbank, and the second sentence, I need to go to bank to make a deposit. And it's obvious, yeah, the word bank is used in very different contexts, and BERT is able to capture this context for each sentence and for each word, and sees the difference. And if you use a bag of words, for example, approach, you probably definitely won't see the difference. And yes, that's just to get some little understanding of the BERT framework, of the BERT architecture. And an important point of BERT is that BERT models are so-called pre-trained. They are pre-trained in an unsupervised way on huge corpora. So, for example, on Wikipedia, or also on tweets, on Twitter data. And so you have pre-trained models which you can use. They already have some knowledge, a lot of knowledge, because Wikipedia is huge, about text. So they are already able to understand texts in general, or social media text, for example, if they're pre-trained on Twitter, like this model down there. And you can use the pre-trained models, and in a second step, you do what your part is. What your part is to fine-tune such pre-trained models with a small amount of annotated data. In our case, we used our housing sample, which was annotated, to make the model, which makes the model highly adaptable to the problem at hand. So it really depends on, okay, I have housing tweets, then the model adapts to housing tweets and the classification of policies within those housing tweets. Or, for example, I have another policy domain or completely different source. So you can just adapt the model to your needs. And we used BERT in our application in two steps. So the first step was used for salience estimation. The second step was used for the position estimation. And the first step, we fine-tune a pre-trained BERT model with annotated tweets of each category and a random sample of tweets not belonging to the issue domain. This was just to optimize the results, because those random tweets, this random sample of tweets was still belonging to the MPs. So it was kind of political context and so on. So we just gave BERT the opportunity to learn more about how politicians communicate on Twitter. And what was done then was that we predict the policy categories on the full corpus of tweets, so on all tweets of the MPs. In the second step, we fine-tuned the pre-trained BERT models with annotated positional stances of each category. And we predicted the positions for each previously predicted policy-related tweets, which were determined by step 1. And in the end, we have the estimates for salience and position. But still, there is one thing that we have users which talk really not that much about housing, which means they have limited data for the positional estimation on the one hand, and on the other hand, on the side of salience, there are tweets which there are users, MPs, which just tweet not that much at all. So we have there, in this case, limited data for salience estimation. So this means that some of them are quite unreliable at this point, on the legislator level at least. To fix this and to have some method to do it, we used partial pooling via hierarchical models. And this is done by using random intercepts for legislators and a so-called shrinkage property. So this means estimates for groups with less cases borrow more average information from the variance of other groups with more cases. And estimates for groups with many cases rely mainly on their own variance. And these models were then applied to salience and position predictions of BERT. And just to show you one equation, for example, for the position model, it is down there. And as you can see, there are also socio-economic characteristics included. The party is included, whether the MP is a housing speaker, because this definitely makes a difference. And the similar equation we used for the salience model. Let's come to some results in the end. So at least some preliminary results. On the left side, as I explained to you, we had two main groups, state and private policies. On the left side, you see state groups, and in the end, on the y-axis, you see the salience, on the x-axis, the ideology from left to right. And you see clear clusters of the different parties and also some outliers. For example, Karen Lay is the housing speaker, so she talks definitely has a high salience, so she talks a lot about housing tweets. And on private, it's more on the right-hand side of the scale. And for example, the AfD is most on the right side, and the Greens on the left side. And I think it's just a good visualization to show some face validity and to show the results. And as I showed you before, we also included socioeconomic features in the model, and we included an interaction of the ownership rate and the rental prices. So this means, with increasing ownership rates, the importance of rental prices for salience decreases for both policy domains. And this was, I think, a little bit stronger in the state category policy domain on the left side than on the right side, but still in both comparable results. And I think this is quite interesting. So coming to an end, talking about the validation first, and then some small outlook. So we know that we have to do more validation steps to show the robustness of the method and validity. But what we already did is, in the first step, we validated our results with birdfish positions on housing topics in national party manifestos. And it showed a similar order and pattern as party aggregated bird estimates. But in the outlook, it's also included that we want to compare the method when we use SVM for the salience support vector machine for the salience estimation, and BERT for the positional estimation, or for example, a dictionary for salience and BERT for the positions. And also to show how much data BERT really needs, we implemented, or we right now implementing just a decreasing of the amount of data used for fine-tuning, of annotated data used for fine-tuning the BERT model, and the second annotation workflow which is just ongoing now. So that's it from my side. By the way, soon, I think in the next few days or something, a Methods Bytes blog post containing additional resources and hints about the Twitter API version 2 will be published. And thanks for your attention. And if you have questions now, feel free to ask them. Thank you.
Perfect. Thank you, Andreas. So we have now roughly 30 minutes for an open floor discussion. So whoever has a question or a comment, feel free to raise your hand in the Zoom chat. Alternatively, of course, you can type your question in the Zoom chat. Oh, but we have one raised hand. I don't see who it is currently. Ruben Bach, please go ahead.
Yeah, hi. Thank you very much. Super interesting. And I was quite curious to learn about the V2 API of Twitter. Do you have any insight on like the success rate in applying for academic access to the V2 API?
Yeah, so thanks for your question. So I think it's not that a problem to get access, and because you just have to like follow the instructions and don't write, yeah, I want to publish all the tweets, and I think then it's fine. So it's, yeah, it won't be a problem, I think. Yeah.
All right, we have a second question from Mario Seltzer.
Hey, thanks for the presentation, super interesting. Specifically the second part for me. So what I would be interested in is, so basically what you're doing, you're using a supervised approach to replace ideological scaling to some degree. So what you're saying is that a position on this topic is basically a subtopic in a topic, right?
Yes.
If I get this correctly.
Yeah.
So the first question is, you lend basically information from others if you don't have enough positional information of the specific issue for an individual, right?
Yes, basically, yeah. So
yes. So do you think that that people who don't communicate a position have a position? That's an interesting question, I think.
It's an interesting question. I think MPs who don't publish anything about their position at all, for them it's really difficult. But if you have at least some housing related tweets in our case, or some domain related tweets and some kind of position, I think it's a good way, or at least an applicable way to lend some of the positional stances of other users.
I'm asking because it's important for your concept. Are you measuring preferences or are you measuring take positions, basically?
What do you mean by the second?
Do you measure preferences, policy preferences, or do you measure taken positions?
Policy preferences.
Yes, exactly. And yeah, this is super interesting, because in the end, what we assume that by having something like a party level policy bundle that you are subscribing to when you're part of the party, you automatically take a position implicitly, but not explicitly. And this is a very deep question, I think, for ideology. So also related to the question whether you take a position if you communicate about rents in the first place. So basically saying in the theory that already talking about this issue makes you more leftist, because it is a very directly communicated issue by, for example, the left party, if you talked about that. Yes. And the second question that I had was, so how well does that work with the 7 subcategories? I mean, how high is the accuracy for this stuff? So my experience is that you have most likely very difficult, rare categories that are also quite imbalanced.
So the problem was, that's also why we at least in the first iteration, then grouped it within state and private for the classification of the categories itself. It worked quite good for 7 categories, but what was definitely a real issue was the ideological prediction, because sometimes we had like not all the positions for one category. So it was just a lack of annotation data. But I think for the category classification it works quite well, also for 7. But for the ideological classification, it was definitely an issue. That's also why we grouped the policies. But in the second iteration of the paper, we annotated more data, so we can try it once more and see if it works better and if we can go back to the 5
out of curiosity, did you try to train the model on the manifesto data before?
Not yet, actually. But I will.
There's this paper that says that you can do it on parliamentary speeches if you train it on by I think Moritz Maber or Moritz Brügger. And yes, and that would be very interesting to me, because what you have now is a validation for these kind of models, and would be super interesting if you fine-tune the model that you trained on the manifesto data, on the Twitter data, whether it works. So again, thanks for the presentation. It's very interesting stuff.
Thanks for your input. It's really good. I will definitely try this out. Yeah. Cool.
Okay, we have 2 more questions in the chat. The first comes from Azle Unan, and the question is, would you have ideas for scraping and or analyzing multimedia or audio and visual or audio visual or either audio or visual Twitter posts?
So I think basically scraping images or audiovisual media data, let's say scraping media data from Twitter, is possible with the Twitter API. There are endpoints where you can do this. And analyzing, there are also usually more sophisticated methods. So for example, with CNN convolutional neural network, that they are more sophisticated, and I'm, to be honest, not sure, but we have to try this out, whether Twitter is really the right place to analyze media data or pictures, or whether you should go to other social media platforms for that. But I think more sophisticated methods should work well for this, for example, CNN.
All right, the next question comes from Mirko Wegemann, who's currently on a train with a bad internet connection, but he posted his question, and it relates to the previous question on the success rate of applications. Are you aware what can be done when an application is rejected? As far as Mirko remembers, Twitter did not allow to reapply, and he did not even know how the application violated the rules.
Okay, that's interesting actually, because like I think in the beginning of the academic research track, so in January 2021, I also tried to apply to the API using not an official academic profile, and they rejected my application. And I think I got some explanation, like some email, and they explained why I got rejected. That's interesting. Maybe also they changed this process somehow. I did not even know how to. I don't know. So it was like almost 1.5 years ago, but I do not really know how to reapply. One way would be to create an additional Twitter account, but I'm not sure if it's a good way, or just write them that you miss some information. But it really depends, I think, what the reason was. But and what's also a good hint, I think, is there is a huge community behind the Twitter developer blog and the whole API. There is a forum where you can ask a lot of questions and maybe just ask there, and yeah, usually they have a solution, I think. Yeah.
All right. On a side note, a comment in the chat by Zach Dickinson also presents an option to go around the API with a corresponding link to GitHub. We have 2 more questions from Felicia Riedmüller. The first question is that, Andreas, you spoke about validating the BERT approach with various other position scaling methods, like Wordfish, for example. So do you consider Wordfish less suitable for Twitter data? And if so, could you elaborate on why that is?
I think it really depends. So in case you want to use like the combination BERT for salience and Wordfish for the positions, then you definitely have or could have the problem that Wordfish works like, yeah, kind of a word frequency approach. So when we compare this with BERT, in BERT you have some contextual representation, as I explained at least a little bit on this slide. So BERT is more able to understand how a human thinks, at least in some point. Yeah, so it sees the ordering, it can see a context, and this, I think, for positions could definitely make a difference. Yeah, because it's not always just I'm against something, but a tweet contains more of contextual and meaningful aspects, which has to be interpreted, I think. Yeah. So yeah, I think BERT could make a difference, definitely. But let's see how the validation approach works, and yeah, whether BERT is able to beat, at least in some cases. Yeah. And also for this, we definitely also have to take a look at maybe other domains and apart from housing.
Yeah, so we'll hopefully have an empirical answer to that question soon. Yeah. Felicia's second question is, how do you deal with retweets? So she's seen many different approaches and wonders whether there are some best practices that are emerging.
So usually when we take a look at MPs, there are a lot of retweets. So the portion of retweets is I do not have the exact number, but I would say like half of them or even more are retweets. And for MPs, we decided to see retweets as like normal tweets, yeah, like they would come from the person, from the MP. But yeah, retweets is one thing. Then there are also quotes, where we decided that we used like the original, like the reply to the retweet when it's somehow housing related. And so I think I'm really not aware that there is some general good practice, because it always depends on the method at hand and on the domain at hand, for to be more specific. But in our case, working with MP data, we use retweets as like normal tweets. Yeah. In case that answers the question. Dennis, I think you're muted.
Oh, true. Sorry. I was just saying, as far as I'm aware, these are the questions that were posted in the chat. Do we have any more questions from the audience? Yes, so Maxi Reifenscheid just raised her hand. Please go ahead.
Yeah, exactly. Thank you very much, Andreas, for this very nice presentation. It was really interesting. I have first a remark on the hint that was given, like working around the Twitter API, which I think is nice. You can have like all the data that you want, but I think it causes a lot of problems if after you intend to publish your analysis, because it is a violation of the Twitter developer terms. And I think Twitter might also look into these kind of processes, and I think it's not such a good idea of doing that unless you only want to do it to practice a bit. Well, that's something I would keep in mind. But if anybody has like another opinion on that, I would be glad to hear it. My question refers back to this picture issue, where I would like to know your opinion, because what I observed on Twitter is that there is quite a bunch of information embedded into pictures, and I think it might be also triggered by a time when there was still this high limitation of characters that you were allowed to send. So I had the impression that some of the Twitter users decided to post pictures instead. And in the pictures, there is lots of text embedded into that. So I think when you only look into the text, you might lose some information, especially if you look at users who are posting on Twitter and maybe the same content at a time on Instagram, or I don't know. So have you considered that for your analysis, or have you ever come across like a publication who considers that? So what is the impact of pictures, and how does it maybe disbalance an analysis which is only based on text?
So it's definitely a good point. And yes, there are a lot of pictures, and sure, we lose information when we do not consider the text, at least, for example, in the pictures. And as you talked about it, I think it also would be not a big deal to extract text from the pictures and use them also in the analysis. But I don't think that I came across some published papers working or like combining it or looking what's the impact of text in pictures. But it's a good point, yeah, and I probably will consider it at some point, yeah. And it's also not that difficult then, because you don't need any very sophisticated models to extract text from pictures. There are already a lot of simpler models which you can apply to extract this text and use it. Yeah.
Okay, thank you.
Thank you.
All right. Do we have any more questions or comments? Yes. So Zachary Dixon, please go ahead.
I'm so sorry, I missed most of this presentation. I'm in the UK and we're an hour behind, so I messed up the time. But is there any way that you would possibly share your slides or share maybe a working paper that you have? That would be awesome. And then also, I just wanted to echo what was previously said about Twint, the GitHub link that I just said. That is indeed, I think, a violation of the terms of service with Twitter. With that said, you can share, say, like Twitter IDs amongst researchers. So, I mean, you probably want some type of plausible deniability, I suppose, if you get your tweets from Twint. But I wouldn't really worry. It's not like it's an illegal thing or something like that.
Yes. Yeah, definitely. Yeah, the Twitter IDs can be shared, sure. And I will also share the slides, and I think the talk is also recorded and will be uploaded to YouTube. So yes, and there will be also the blog posts on methods bytes. So yes, sure.
And just to add to that, in terms of working papers, Andreas and I are actually working on 2 papers here, one of which is co-authored with Tim Allinger, who I believe is also here in the meeting today. So one is a substantive application to the question how German MPs politicize the housing issue, and the other is a research note that's really more focused on the methodological framework and the validation aspect. And we will present them at more places than I can count. So I think the first presentation will be at AK Wahlen in 2 weeks. Then shortly after that, here at the MZES in the Political Science Departmental Colloquium. After that, Andreas, you're going to do a poster session at PolMeth Europe in Hamburg. And then we'll be at EPSA in Prague. So plenty of opportunities to see where this is going to go in the next couple of weeks and months.
Thank you, Dennis.
All right. Anything else? Okay. In that case, thank you so much for presenting your work today, Andreas, and for the blog post that you are going to contribute soon. Thanks so much for the audience, for the attendance and the great discussion today. And we will be back in about a month's time, so in 4 weeks. There's been a slight change of schedule. Teresa Gessler is going to present her work not on May 23rd, but in fall of this year. And instead, Chung-Hong Chang from the MZES is going to present on June 1st. Usual time, Wednesday, 1:45 Central European Time. Thanks so much, and we hope to see you soon. Bye-bye.